Hello friends, welcome back to our channel Ahaj in the Edu-Care. Our channel provides learning resources of maths and science from class 8 to 12. You may visit playlist and see class-wise resources of math and science. Our channel is new, so slowly and gradually we are putting videos related to math and science for each class. Okay, friends. So, coming back to the topic matrices, in last lecture of matrices, we have covered what is a matrix, what are various types of matrices. Under the operation of matrices, we have discussed addition, subtraction, multiplication, and scalar multiplication. Then we have seen what is how to calculate trace of a matrix, transpose of a matrix. Then we have seen how to calculate adjoint of a matrix and inverse of a matrix using adjoint. Then we have seen row and column transformation. Okay, friends. So now we will discuss today's solutions of linear simultaneous equations using matrix method. Okay, friends. So those who have not seen our previous lectures, please follow the link given in the description box so that you can easily understand this lecture. So we will start with solution of linear simultaneous equations. So solution of linear simultaneous equations using matrix method. So we will solve linear equations using matrix method. Okay. So let us consider a system of n linear equations in n unknowns. So let x1, x2, x3 up to xn are n unknowns and number of linear equations are n, so that we can solve this. If number of variables is n, we need n equations to solve the equations and get values for each variable. Okay, friends. So let x1, x2, x3, xn are n unknowns, and below are n linear equations. Okay. So linear equations we will assume as a11x1 plus a12x2 a13x3. Similarly, last one will be x1n, since there are n number of variables. So xn equal to, let it be b1. Second equation is a21 x2 x1 plus a22 x2 a23 x3 a2n xn equal to b2. Third equation a31 x1 plus a32 x2 a33x3 and last a3nxn equal to bn. Okay. Similarly, there will be other equations. We will write the last equations. So last equation is an1x1 plus an2x2 plus an3x3, and last one will be ANNXN equal to, this is your B3 and this is BN. Okay friends, so if B1, B2, B3 are all 0, then system of equation 1. So if these are system of equations, let it be 1. Okay, so if B1 equal to B2 equal to B3 or all these are 0, then equation 1, system of equations 1 is called homogeneous linear equations. Homogeneous linear equations. Okay, so what are homogeneous linear equations? If all these are 0, then the system of equations given by 1 is called as homogeneous linear equations. Okay, equations. And if at least, even if a single b is non-zero, then it is called system of non-homogeneous linear equations. If at least one of b1, b2 or any one of up to bn is non-zero, it is called system of non-homogeneous linear equations. Okay, so we can write the system of linear equations given by 1 in matrix format, where we can write, see, I will write on the right side. So we can write it as, we need some more space. Okay, we will try to adjust here. Okay, so A11 we will write in matrix from A1 to A13, and last element will be A1n. Second row will be A21, A22, A23, and last element will be A2n. Third row will be A31, A32, A33, and last element will be A3n. Right? So next, last row will be AN1, AN2, AN3, and last element will be ANN. Right? So this is our one matrix. Other matrix will be, see, when this we will multiply with, so this is also a matrix x1, x2, x3, xn. Okay, xn, and RHS will also be, we will write in the matrix form. So it will be B1, B2, B3 up to Bn. Okay friends. So the given linear equations can be represented in matrix form like this, or we can write capital A into X equal to B, where A is our this matrix, X is x1 next to this matrix, and B is this matrix. This is your B, this is your capital X, and this matrix is A matrix. Okay, so we will clear here and we'll, or just I need some more space. So I will clear this portion. Okay. Now we know AX equal to B. So this will be continued this side. So AX equal to B. So we can multiply A inverse on both sides. So A inverse of AX equal to A inverse into B. Okay. Or we can write A inverse A into X equal to A inverse B, and we know A inverse into A will be a identity matrix, so we will write I into X equal to A inverse into B. Okay, so can we calculate X from here? Yes, we can calculate X from here, and it will be A inverse B, and A inverse we know will be adjoint of A into B divided by modulus of A. So adjoint of A by, sorry, this is discriminant of A is adjoint of A divided by discriminant of A is your A inverse, and B we will multiply to get X. Okay friends, so this is the base of linear equation solution using matrix method. Now we will see types of equations, then we will proceed with problems. So types of equations we see. Types of equations. First type is when system of equations is non-homogeneous. That is, any B is non-zero, either P1, P2 or up to Pn. Any of the B is non-zero, then system will be non-homogeneous. When system of equations is non-homogeneous. Okay. So in this case, the possibility will be if determinant of A is not equal to 0. When determinant of A is not equal to 0, then system of equations is consistent. System of equations, here also we will write equations. System of equations is consistent and has a unique solution given by, and has a unique solution given by x equal to, as just we have discussed, x equal to A inverse B. A inverse can be calculated using adjoint formula, that is adjoint of A by displacement of A. Okay. So second case will be if determinant of A is equal to 0 and adjoint of A into matrix B is not equal to 0. So in this case, then system of equations is inconsistent. System of equations is inconsistent. Okay, and has no solution. And has no solution. Third case we may see if determinant of A is equal to 0 and adjoint of A into B is also 0 or null matrix we can say. So adjoint of A into B is also 0 or null matrix, then system of equations is consistent. System of equations is consistent, right, and has infinite number of solutions. And has infinite number of solutions. So in type of equations, first type will be when system of equations is non-homogeneous. In this, there are three cases. First is determinant of A is not equal to 0. Then system of equations is consistent and has unique solution. Second case is determinant of A equal to 0 and adjoint of A and to B is not equal to 0. In this case, we will have no solution. Third case is determinant of A equal to 0 and adjoint of A into B is also 0. Then system of equations will have infinite number of solutions. Then we will see second type when system of equations is homogeneous. System of equations is homogeneous. Okay, so in this we will have case like the first one. If determinant of A is not equal to 0, then system of equations has only trivial solution. System of equations has only trivial solution and it has one solution and it has one solution. Okay, second case may be if determinant of A is equal to 0, then system of equations has non-trivial solution. System of equations has non-trivial solution and it has infinite solutions. It has infinite solutions. Third case, if number of equations is less than number of unknowns, if number of equations is less than number of unknowns, then it has non-trivial solutions. Then it has non-trivial solution. Okay. So when system of equations is homogeneous, in this case we have three possibilities. First one, determinant of A is equal to 0, is not equal to 0, then system will have trivial solution and will have one solution. Second possibility, determinant of A equal to 0, then system of equations has non-trivial solutions and it will have infinite number of solutions. Third possibility, number of equations is less than number of unknowns, then it has non-trivial solution. Okay, friends. We will solve some problems based on this discussion. So let's clean this. Write down the question. Solve the system of equations. Solve the system of equations given by x plus 2y plus 3z is equal to 1. Second equation is given as 2x plus 3y plus 2z equal to 2 and 3x. Third equation is 3x plus 3y plus 4z is equal to 1. So we will solve it with the help of matrix method. So how to proceed? See, as three equations are given, so we will write this in the matrix form. Okay. So writing the given equations in matrix form, we get what will be equations. See, x plus 2y plus 3z. So we will take coefficients of x, y and z. So it will be 1, 2, 3. Then second equation 2x plus 3y plus 2z. So 2, 3 and 2. Third equation is 3x plus 3y plus 4z. So coefficient of x 3, coefficient of y 3 and coefficient of z 4. Then x, y and z we will take as matrix x, y, z. Okay, I will write it clearly. X, y and Z. This will be equal to the constant terms on the right side of equations, that will be 1, 2 and 1. Okay. So based on this we can write Ax equal to B, or X will be equal to A inverse B. So what we have to do here, so in this equation we have A equal to 1, 2, 3, 2, 3, 2 and 3, 3, 4. We have matrix X as X, Y and Z, and matrix B we have 1, 2, 1. Okay. So in order to find X, first we need to see this equation. You can see this equation. We have to first find A inverse and then we have to multiply with B. Okay. So first we have to find A inverse. So we will find matrix of cofactors so that we can calculate the adjoint. So if we, I think all of you remember, so cofactor matrix, we can write it as, see this 1 for first term, this will be plus, so 3 into 4, here only you see 3 into 4 minus 3 into 2, so 6. 6. Then next one will be, it will be minus, so 2 into 4 minus 3 into 2, so 8 minus 2 and minus we will put before this, so minus 2. Third will be 2 into 3 minus 3 into 3, so it will be minus 3. Similarly, we can write other elements as 1, minus 5, 3, minus 5, 4, minus 1. So this is a matrix of cofactors. Now we know adjoint of matrix A will be given by transpose matrix of cofactors. Okay, C transpose, which is equal to 6 minus 2 minus 3, 1 minus 5, 3 and minus 5, 4 minus 1. We have already discussed how to find the transpose of a matrix. Please, if you don't remember, go through the previous lectures of matrix so that you can easily understand this. Okay, friends. Now we have found A adjoint of A. Next, what we have to do, we will find mod determinant of A. So determinant of A we can write as 1, 2, 3, 2, 3, 2 and 3, 3, 4. So expanding this we will get 1 into 12 minus 6 minus 2 into 8 minus 6 plus 3 into 6 minus 9. So it will be 6 minus 4 minus 9. Okay. So it is equal to minus 7, which is not equal to 0. Now we remember it is a type of homogeneous equations. Okay. The system of equations given are non-homogeneous equations, and determinant of A is not equal to 0. Okay, friends. So this will have unique solutions, and A inverse will exist. So A inverse is given by adjoint of A divided by determinant of A. So this is equal to 1 by minus 7, and determinant and adjoint of A is 6, 1 minus 5, minus 2, minus 5, 4, minus 3, 3, and minus 1. Okay, so this will be equal to, we will divide each element by minus 7. So minus 6 by 7, minus 1 by 7, 5 by 7. Second row will be 2 by 7, minus 5 by minus 7, so 5 by 7, and third will be minus 4 by 7. Third row will be, third row will be minus 3 by minus 7, so 3 by 7, and then 3 by minus 7, so minus 3 by 7, and last will be 1 by 7. Okay, so we have calculated A inverse. Now as we know x, y, z, okay, x equal to A inverse of B, x equal to A inverse B. So we have x equal to x, y, z, and then we will calculate A inverse, as this is A inverse. So we will write minus 6 by 7, minus 1 by 7, 5 by 7, 2 by 7, 5 by 7, minus 4 by 7, 3 by 7, minus 3 by 7, and 1 by 7. This we have to multiply with matrix B, which is 1, 2, 1. Now on multiplying, as I need more space, so I will delete left side. Okay, so I am deleting this. Okay, friends. Now we know multiplication of two matrices. So x, y, z will be x, y, z. Okay. After multiplication, see, minus 6 by 7, minus 2 by 7. So first row we have to multiply with column of B. So minus 6 by 7 into 1, minus 1 by 7 into 2, plus 5 by 7 into 1. So it will become minus 6 by 7, minus 2 by 7, plus 5 by 7. Okay. Second row will be, all the row will have one element only. Second row will be 2 by 7, plus 5 by 5 into 2, 10 by 7, minus 4 by 7. Okay, this is just 10 by 7. Then third row will be 3 by 7, minus 6 by 7, plus 1 by 7. So we will get this as, if you see, minus 6 to minus 8 plus 5, so minus 3 by 7. Second row will be 2 plus 10, 12 minus 4, so it will be 8 by 7, and third will be z, 3 by 7 minus plus 1, 4 minus 6, so minus 2 by 7. So when we compare this xyz with this one, we will get x equal to minus 3 by 7, y equal to 8 by 7, and z is equal to minus 2 by 7. So this is our required solution. Okay friends. So we will take another problem and we will consider next homogeneous types of equations. Okay friends. So another type we will take. Solve the system of given equations. Solve the system of equations given by x plus 3y minus 2z is equal to 0, 2x minus y plus 4z equal to 0, and third is x minus 11y plus 14z is equal to 0. Okay friends. So we can write the given equations in matrix form. What we will get 1, 3. We will write coefficients of x, y and z. Okay. So 1, 3 minus 2. 2 minus 1, 4. 1 minus 11 and 14. So this is our matrix A, and variables we will write as x, y and z. Then we will get matrix P as, or it is a homogeneous equation, so all will be 0 and it will be a null matrix. Okay friends. So if we see, we have equations of the form Ax equal to null matrix. Okay, where A equal to, what is our matrix say? 1, 3 minus 2, 2 minus 1, 4, 1 minus 11 and 14. Matrix X is equal to x, y and z, and matrix O or null matrix is, all the elements will be 0. Okay friends. Now we will calculate determinant of A, which is given by 1, 3 minus 2, 2 minus 1, 4, 1 minus 11, 14. So this is equal to 1 into minus 14 plus 44, then minus 3 into 28 minus 4 minus 2 into minus 22 plus 1. So it will be 30 minus 72 minus 21 into minus 2, so 42 equal to 72 minus 72, which will be equal to 0. So now we have seen, in case of homogeneous equations, if determinant of A is equal to 0, then system will have non-trivial solution and will have infinite number of solutions. Okay. So next, how we will proceed to see this, as determinant of A is equal to 0, system of equations has or none has a non-trivial solution. Okay, so we can write the first two equations as x plus 3y equal to 2z and 2x minus y equal to minus 4z. Solving these equations, and we will try to solve and find x and y in terms of z. We will get this, we can write 1, 2. So solving 1 and 2, we get this is our 2 number, x equal to minus 10 by 7 z and y equal to 8 by 7 z. Okay, so we will substitute x and y in the third equation. So our third equation is x minus 11y plus 14z equal to 0. So we will substitute x as minus 10 by 7z and y is minus 11 into 8 by 7z, okay, plus 14z. So we will substitute in this, only in LHS we will put, so RHS we should not write here, and we will check whether 0 is coming or not. So this will be equal to so now we will see minus 10 and minus 88, so minus 98 by 7, so minus 14z plus 14z, it will be equal to 0. Now we can assume let z equal to 7k, as see x and y have 7 in the denominator, so we will consider z equal to 7k. Then we will have x equal to minus 10k and y equal to 8k. Okay, hence x equal to minus 10k, y equal to 8k and z equal to 7k are required solutions. Okay, here k is any arbitrary constant. We put any number in place of k. We will get a solution for x, y and z. So in this case, we will have infinite number of solutions. Okay friends, so today we have seen solutions of linear simultaneous equations using matrix method. I hope every one of you have understood this lecture. If you have any doubt, please let me know in the comment box. I will try to clarify your doubts. Okay friends, and if you have seen the whole video and liked the video, please like it and subscribe our channel Aha Jindagi Edu-Care. Also press the bell icon button so that you will get notification when next video will be uploaded. Okay friends, thank you.